Welcome to LabMinutes.com. In this video, we'll be looking at DHCP configuration on a Cisco router and a switch. I would assume that most of you are probably familiar with the DHCP, so let's dive into our lab. So in this lab, we'll be using a switch 1 for our local DHCP server, and R2 is going to be the client that will attempt to obtain the IP, and R1 later on in the lab will be a remote DHCP server. So starting on switch 1, let's take a quick look at the different DHCP options. First command is IP DHCP config locking. Although this is turned on by default, what it's going to do is once it's detected a duplicate IP is on the subnet, it will lock, or it will present a lock messages. Then we do DHCP ping packet. So this is the number of packets, the number of times the switch would attempt to ping the IP that's about to hand out to the client, and if it detects the IP is already exists, it would not use that IP. So it detects the duplicate IPs. Ping, we'll do it 3 times, and each time we're going to do a timeout of 300 milliseconds. The next command is DHCP exclude address. So if there's a block of IP you'd want to reserve and not be handed out to the client, this is how you would define that block of IP. Here we're going to reserve the first 31 IPs of the subnet, so up to 31. So the first starting IP will be 32. Next we'll define the pool, and we'll call it VLAN 128. And the options that we have is the default router, which is the default gateway the client will use. We have a DNS server, a domain name, lease time. If you have a NetBIOS name server, you also define it right here. And the first command we would do is the network 172.16.128.0 to specify the subnet of the pool. And you can do the slash version of subnet mask or the full subnet mask. Here we're going to do the slash 24. Next we'll tell that the default router for the subnet is the switch 1 that has the IP of 172.16.128.1. They'll give a domain name, LabMinutes.com. With the DNS server, we don't really have one, we're just going to be pointing to R1 IP, which is 16.32.32. And the last command we're going to do for now is define the lease time, starting with day. So we can say 0 day, 8 hour, and 0 minute. Okay. Okay, everything looks good. Now we're going to prepare to test. So we're going to enable debug IP DHCP server packet. We can also do server event, just to show you a different debug option, and the other one's linkage. So that should be ready. We clear the screen. We also going to fire up our Wireshark. Let's make sure we are spanning the FAS 02 on the switch. Okay, looks like that's not configured, so let's go ahead and create a monitor session so we can observe the DHCP packets. Let's call 1 source interface FAS 02. By default it's send receive, and then we're gonna set the destination interface to our capturing PC. Okay, now we're going to set up Wireshark. Pick your interface. We're going to put on packet capture, so all we need to see is UDP 67, which is the client-side ports. Port, start, have that run in the background. Now let's configure the DHCP client on R2. So the configuration is going to be on the FAST00 interface, IP DHCP client, and we're going to do a default router. So tell the client to use the default route or default gateway being learned through DHCP. Going to give it a distance or administrative distance of 1. Then going to do IP address. Instead of putting the address as usual, we're going to set DHCP. Okay, so show debug. We have the debug ready. Then we're going to do no shut. Okay, looks like the R2 already received the IP. There you go. Although we're not seeing that on a Wireshark capture, so let's make sure we have that set up properly. Oh, that's why. So it's supposed to be 67. Let's start again. And on R2, you can easily do DHCP, or actually release DHCP FAST00. You can see the release packet has been sent, but let's start over. Now we're going to do renew DHCP FAST00. Okay, now we're seeing all the packets and debug messages. So let's take a look at what we have. So in R2, since this is the second time it requests for IP, the first time it got .32, this time the switch handed out the next available, which is .33. Okay, we do show IP route. And see, it's also learned the default gateway, which is 128.1, as designated by static route. If we do show host, it's also learned the domain name LabMinutes.com. And we definitely did not manually configure the domain name. Okay, so take a quick look at the debug messages. The first message, the switch received DHCP discovered. Then it assigned the next available IP .33. It sent back DHCP offer. The R2 sent a DHCP request with the assigned IP, and switch 1 reply with the ACT packet. And here you can also see a client ID, which we will save for our next part of the lab. Copy. Just gonna put it here for now. Now on our Wireshark, the first packet was the discovered packet coming from R1 to a broadcast destination IP, as well as the broadcast MAC address. The port is source port 68, and which is the client side port, and 67, which is the server side port. So designated by the S, which is server, and C is the client. Now looking at the payload of the packet. There's not much to see at this point. It tells the host name is R2. Then switch 1 replies with an offer, and it has the IP in the payload .33 with all the parameters that we configured. So DHCP offer default, or this is itself IP. Lease time 8 hours, renewal time, which is usually half of the lease time, 4 hours. Subnet mask, default gateway, domain name, and DNS server. So all the options are contained in the payload. Then you see the request coming from the R1, not R1, R2, requesting .33 IPs, and switch 1 replies with the final act. Okay, so let's move on to the next part. The next thing we're going to try is to do a host IP reservation or MAC address reservation. So right now we are going to, let's clear the screen. The way to do that is we come up with a new pool. We're going to call it R2. Here it requires you to specify the IP that you want to hand out to that particular host. So here we're going to choose 16, which is an IP from our reserved block or excluded block. And the other parameter you need is the client identifier. And that's where the string that we copied earlier is going to come into play. So that, paste, enter. Okay, we're going to go back and do IP DHCP debug with the server packet, server event, clear the screen, tell R2 to release DHCP. Okay, renew DHCP. And you can quickly spot the .16 IP was handed out to R2. It's also confirmed by the log message right here. And we can see now it received a .16. So that's how you would reserve an IP for a device individually. So if you do it this way, let's see, show run. Okay, show IP route. So R2 still learn the default gateway, although it's not defined under the individual pool. And that's because it's smart enough to look at the existing pools that has all the parameter defined, and we'll just use those default parameters. So you actually need to define the pool with all the parameters, and then a separate pool that does the MAC address, or in this case, a client identifier to host IP mapping. Okay, next we're going to look into a DHCP Relay functionality. So now that we're going to disable DHCP server function from switch 1. So we're going to delete the pool, both pool that we created, and we might as well delete that too. Okay, but at this time we're going to tell switch 1 whenever it receives a DHCP request broadcast, we'll have it forwarded to R1. So the broadcast will be coming in over interface VLAN 128, and the IP to tell it to forward the broadcast and actually turn into a UDP unicast is the helper address pointing to the DHCP server, which is R1. Okay. For that helper address command to work, you need to make sure you have a service DHCP command turn on, which is again turned on by default. And you also need to make sure you have an IP forward protocol, UDP, boot, CNS, and those should also be enabled by default. So if you look for forward, it shows up. Now we're going to go back, scroll back a little bit, and copy the exact same configuration and paste it on R1. Still have debug turned on, and we're going to turn on debug, IP DHCP server packet, and event from R1 for okay, and we're going to modify our span session, so we will be looking at the interface FAST00 and R1. So changing that from FAST02 to FAST01. Okay, and we're gonna restart our Wireshark. And on R2, same thing, release. Just clear the screen for a sec, and then renew. Okay, it looks like it completed, but for some reason we are not seeing anything on the captured again. So let's see why. Oh, okay, looks like we forgot to remove the null earlier. Let's do that. Gonna do release. And renew. And now we're seeing the packets. Now from the switch 1 perspective, it receives the local DHCP request broadcast, and you can see right here it said forwarded, received the request message and then forwarded to the IP we specified into the IP helper address. On R1, it's received a discovered message. It's go through the same process. So if you look at the Wireshark packet captured, instead of a broadcast message, now it's an actual UDP unicast message, and the destination being the server. Still, you have 4 messages to complete the process, but one thing to notice is now you have a relay agent IP embedded in the packet. So this is how the DHCP server determines which pool of IPs or DHCP pool it should be assigning the IP from. Okay, and on R2, and again, before I grab .32, I just grab .33. Okay. Now, if your DHCP server support or require option 82, which is additional information that you can get from the relay agent, which in our case is a switch one, there's a command that you can enter to enable option 82, and that command is the DHCP Relay information option. Okay, so let's issue that command, and let's start up a new window of Wireshark. UDP port 67. Oh, I forgot to change the interface. Here, start. Okay, and we get R2 to release. And renew. And if you look at the DHCP discovered packet, you see now there's a additional option 82 added with the agent information, although it's not so much readable. And if you compare that to the packet that we captured earlier, you can see there was no option 82. Okay. So the final feature that we're going to look at is how to do a IP to MAC address reservation in bulk. So before you were able to create an individual pools, one per client, to the reservation. There's also a second method to do that by defining a text file that contains the table of the client ID and IP mapping. So here we already have a text file created and stored on our flash on R1. So if we do more flash dhcp.text, you can see this text file. It has to be in a particular format starting with time, and there's various columns you have to do. First column is IP address, and then with mask type we do ID, the hardware address, and these are the hardware address that we always sees in the debug, and leads expiration we're going to do infinite. Okay, so the way to utilize that file, we're just going to get under the pool, remove our network, and the command is origin file, and then we do flash dhcp.text, and now if we do show IP DHCP binding, you see our content in that table is now show up in the binding table. So now if you go back to R2 and do a release, and renew, you can see now I just obtained .16 as defined in our mapping file. So instead of having to create, for example, you have like 50 hosts you need to do a MAC reservation for, there's no need to create a 50 individual DHCP pool. You can just define 50 lines of mapping in this one particular file, and you should be all set. Okay, so that wraps up our video on DHCP. Thank you for watching LabMinutes.com, and I'll see you in the next video.